Okay, we're going to do problem 25 in section 3.3. So it says find the intervals on which the function is increasing or decreasing, and find the relative maxima and relative minima of f. The function here is f of x equals 2x minus 3 over x squared minus 4. So f of x equals 2x minus 3 over x squared minus 4. Might not hurt to look and see where the function is defined, what the domain is. Notice that this would factor as x minus 2, x plus 2. So the places this rational function would not be defined would be at 2 and negative 2. So the domain you might write as all x not equal to 2 or negative 2. Okay, the point here is we're supposed to take the derivative. I'm going to have to use the quotient rule here. So low d high minus high d low. Whoops, that was a mistake. Low d high is x squared minus 4 over times 2, that's the derivative of the top, minus high 2x minus 3, d low is 2x, all over low squared. So let's see what that comes out to. In the numerator, what we have is we have 2x squared minus 8 minus 4x squared plus 6x all over. Now here what I have is I have x plus 2 times x minus 2 and the whole thing squared. So that means both individual terms are squared. So let me sort of simplify the top here. I have negative 2x squared. Then I have plus 6x, negative 8, all over x plus 2 squared, x minus 2 squared. You know, I can factor out a negative 2 out of the top. I don't know what that'll do for me, but it might be easier to see what's going to happen if I have x squared minus 3x plus 4 over x plus 2 squared, x minus 2 squared. To find the critical points, I need to figure out where the derivative is 0, that's where the numerator is equal to 0, or where it's undefined, where the denominator is equal to 0. Now, the denominator is fairly easy. The numerator, I'd have to think about how to factor that. So can I think about a way to factor this as two things? Let's see, they multiply to a positive, so both the signs would have to be negative since they're supposed to add to negative 3. What things could multiply to 4? Well, 1 and 4 and 2 and 2. Neither of those add to 3, so that's a good indication I'm going to have to come down and do the quadratic formula to try and figure out, is there an x value that'll make that equal to 0? So, will x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. You can see that this is 9 minus 16, which means there's no real value that makes the numerator 0. That means, you might write non-real there. That means there's no 0 for this function, but there are still critical points, or critical values, or critical numbers, whatever you want to call them. X equals 2 and x equals negative 2 are critical numbers. And so if you do a number line breaking your domain between negative 2 and 2, notice those points are also outside the domain. So those can't actually be relative maxes or mins. They're not in the domain. We know that the derivative is undefined at both those points. Now, I'll probably go to this form right here. I want to know what happens if x is greater than 2. Well, if it's greater than 2, this is still negative. Greater than 2, you know, if x is 1,000, this thing is certainly positive. This is positive, that's positive. Only one negative sign means I'm decreasing over here. If I'm between these two values, let's say 0. 0 is an easy point to plug in. I've got a negative. This would be a 4, so negative, positive. These are both squared, so it's positive, positive. This is all still negative. Okay. Then let's pick something a really large negative. Let's say negative 1,000. This is negative. Negative 1,000 squared is still a large positive, so this thing's still going to be positive. These are both squared, so they've got to be positive. So negative, positive, positive, positive. So I have an interesting situation here where my function is decreasing from negative infinity to negative 2, from negative 2 to 2, from 2 to infinity. These are not relative extrema, and I don't have any increasing interval.